A pump draws water from reservoir A and lifts it to reservoir B as shown. The loss of head from 1 to 2 is 3 times the velocity head in the 6-inch pipe, and the loss head from 3 to 4 is 20 times the velocity head in the 4-inch pipe. Compute the horsepower output of the pump and the pressure heads at 2 and 3 when the discharge is 200 gallons per minute. So this is the figure for this problem. There are two reservoirs, A and B, and the liquid from reservoir A is transferred to reservoir B. So the problem uses a pump to transfer the liquid from this tank to this tank. The suction side of the pump is 6 inches pipe and the discharge side is 4 inches pipe. The loss of head from this point to this point at 6-inch pipe is 3 times the velocity head at this pipe. And also the loss of head from point 3 at the discharge of the pump to point 4 is 20 times the velocity head in the 4-inch pipe. We are asked to compute the horsepower output of the pump and the pressure heads at point 2 and point 3 when the discharge is 200 gallons per minute. Now for this figure, the given elevation at point 4 is 120 feet and the elevation at point 1 is 0 feet. And since point 2 and 3 are lower than 1, so the elevation is negative 20 feet. Okay, so this is positive 120, this is 0 elevation, and this is negative 120 feet. Now the velocity at the surface at 4 and 1 are 0 because the velocity is negligible compared to the velocity at the pipe. The velocity of 3 of course is not equal to 0. This has a velocity, and also the velocity at point 2 is not equal to 0. Now the pipe cross-sectional areas can be computed using the given diameter of the pipe. So the cross-sectional area of point 2 given the diameter of the pipe equal to 6 inches. So you can compute for the cross-sectional area of that is pi d squared over 4. So that is 0.237 square feet, knowing the diameter equal to 6 inches and the cross-sectional area sub 3 given the diameter of the pipe equal to 4 inches. You can compute that using pi d squared over 4, that is equal to 0.087 square feet. Now the velocities at the pipe given the value of Q equal to 200 GPM. So Q is equal to 27.738 cubic feet per minute. So we can compute for the velocity at point 2 inside the 6-inch pipe. That is Q divided by A. So that is equal to 113.03 feet per minute or 1.884 feet per second. You just divide this by 60 seconds per minute. Now the velocity at point 3 can also be computed using this equation. So this is Q, 27.738 divided by A. So that is equal to 5.1 feet per second. So bakit kinocompute natin itong mga velocities at 2 and 3? Because we have to compute for the head loss at point 1 to 2 and head loss at 3 to 4. So they are given here. This is 3 times the velocity head. So the velocity head at point 2 is B sub 2 squared over 2G, and the velocity head at point 3 is represented by B sub 3 squared over 2G. So knowing B3 and B2 and G, we can compute for the head losses from this point to this point and from this point to this point. So we compute for the velocity head at 2. So that is knowing the velocity at 2 is 1.884 and using G equal to 32.2 feet per second squared. So the velocity head is 0.055 feet, and at point 3 using the computed value of V sub 3, 5.1 feet per second. So we get here the velocity head at point 3 is 0.405 feet. Now the head losses, you just multiply this by 3. 3 times this one, 0.055, that is 0.165 feet. And the head loss from 3 to 4 is 20 times the velocity head, 20 times 0.405, or that is equal to 8.1 feet. So yan ang mga head losses dito. Okay. Now, knowing now the head losses, we can now derive the Bernoulli's energy equation from 1 to 4. Okay, so the BE from 1 to 4 is the velocity head at point 1, the pressure head at point 1, plus the elevation head at point 1, plus of course the pump head. This is equal to the velocity head at point 4, pressure head at point 4, and elevation head at point 4 plus the head losses. So we have studied this in our previous discussion that the pump head is added at the left side and the head losses are added at the right side of the equation. So V1 squared over 2G is approximately equal to 0 since the velocity at point 1 is almost equal to 0. The pressure at point 1 is also equal to 0. So you cancel that. The elevation at point 1 is 0. That is given in the figure. And we don't know the pump head, so we just place here H sub P. Then the velocity at point 4 is 0. So that is the velocity at the surface. The pressure at point 4 is also equal to 0. Then we have the elevation head that is 120 feet. And the head loss, we have computed that is equal to 0.165 plus 8.1, or that is equal to 8.26, rounded to 2 decimal places. So what is left in the left side is the pump head. So 120 plus 8.26, that is 128.26 feet. Now the power of the pump can be computed using this equation. Power is equal to Q omega E. Q equal to 27.738 cubic feet per minute. And for water, the specific weight is 62.4 pound per cubic feet. And the computed E, the pump head, is 128.26 feet. So the equivalent power of this one is 214,002 pound-feet per minute, or that is equal to 6.48 horsepower. Knowing that 1 horsepower is equal to 33,000 pound-feet per minute. Now we go to the pressure heads at point 2 and point 3. So the pressure heads at point 2 and point 3, this can be found using again the Bernoulli's energy equation. So the pressure head at point 2 can be found, but this time we will use BE from 1 to 2. Kasi ito yung particular na hanapin natin, yung point 2. So that the pressure head will appear in the equation. Kasi kung gagamitan natin siya ng halimbawa ganitong 4, so wala diyang pressure head at point 2. Ang makikita mo dyan is 1 to 4, okay, P1 and P4, because the Bernoulli's energy equation at this instance is from 1 to 4. Now to compute the pressure head at point 2, so we have here B1 squared over 2G plus P1 over W plus Z1. So tatlo lang yung term dito, the velocity, the pressure, and the elevation head. Now at point 2, we have here B sub 2 squared over 2G, then the pressure head P2 over omega plus the elevation head at 2 plus the head loss 1 to 2. Now again, B1 is approximately equal to 0. The pressure at 1 is also 0, and the elevation from the given value that is equal to 0, B2 squared over 2G, so this is not equal to 0 because there is a velocity in here. Of course, P2 over W is not equal to 0. So yan ang hinahanap natin. This is the pressure head at point 2. Itong P2 over omega. Then, the elevation at point 2 is negative 20. The head loss from 1 to 2 is 0.165 as we have computed in this part. Head loss 1 to 2, 0.165 feet. Now solving for P2 over omega from this equation, since the left side of the equation is equal to 0, so we transpose all other variables and constant to the left side, and we retain P2 over omega on the other side. So P2 over omega is equal to negative V sub 2 squared over 2G. So ililipat natin yan dito. So yung negative 20 ay ililipat natin, magiging siyang positive 20. Yung positive 0.165 ililipat natin, magiging siyang negative 0.165. Now, the velocity head, this is already computed, B2 squared over 2G. So nandito siya, B2 squared over 2G is equal to 0.055 feet. So that is negative 0.055 plus 20, negative 0.165, or P2 over W is equal to 19.78 feet. So this is the pressure head at point 2, 19.78 feet. And if you want to convert that, the actual pressure, the gauge pressure, so you will just multiply this 19.78 feet times the value of omega, 62.4 pound per cubic feet. So that is equal to 1234.25 pound per square feet. But what is required in this problem is the pressure heads. So the answer for this one is this one, 19.78 feet. So this is the pressure head and this is the pressure. Now to compute for the pressure head at point 3, dito naman sa kabila, you can use BEE from 2 to 3, or you can use BEE from 3 to 4, or you can use BEE from 1 to 3. So tatlo ang pwedeng gawing equation. Pwede siyang 2 to 3, 1 to 3, or 3 to 4. So using BEE from 2 to 3, so the Bernoulli's energy equation will be B2 squared over 2G plus P2 over omega plus C2 plus pump head. So meron kasing dadaanan na pump, so we have here plus HP or pump head. And at point 3, B3 squared over 2G plus P3 over omega plus C sub 3 plus head loss 2 to 3. Now, since head loss from 2 to 3 is not given in this problem, so we assume that the head loss from 2 to 3 is equal to 0, because the given head losses are from 1 to 2 and 3 to 4. So this head loss here will be equal to 0. Now the C3 and C2, the elevation at 3 and 2 are similar. That is negative 120, and also this one negative 120. So B2 squared over 2G is computed 0.055. P2 over W we have computed, that is 19.78. So here 19.78, and the velocity head is 0.055 B2 squared over 2G, and the pump head is 128.26. So yun naman na-compute natin sa pump, this one, 128.26. So the elevation is negative 20, and the velocity head at 3 is 0.405. So computed din yan dito sa previous slides. Yan, B3 squared over 2G is 0.405. Then we write P3 over omega. So again, this is negative 120. The elevation at point 3, and the head loss from 2 to 3 is 0. So from this equation, what is left unknown is the pressure head, P3 over omega. So that is equal to 147.7 feet. And if you want to compute the pressure at this point 3 here, so you just multiply this by the omega, 62.4 times 147.7, then we have here 9216.1 pound per square feet, or that is equal to 64 psi. So this one is our answer from the requirements of the problem.